Okay. Today is
Yeah, so we're
the
good.
healthcare and no, but today is the healthcare insurance firms.
Okay, so we can start.
Yeah, but it is the
We,
healthcare.
yes, yes.
Okay. Okay. Hello, everybody. I'm Gina from Byteflow Dynamics. Welcome again to our new series that plays every day at 12 p.m. Eastern Time. Today, as always, we have Andy Shehu. Hello, Andy. How
Hi,
are
Gina.
you?
Good, good. How are you?
I'm fine. A little bit cold, but it is fine.
Okay, yeah.
It's good. Okay. Today we're talk about AI with in healthcare and insurance firms.
Mm-hmm.
It's a project that you develop, if I remember correctly.
Mm-hmm.
So everybody out there, we welcome your questions if you have any, and probably we're gonna cover also the advisory part, right?
Yeah.
So go for it.
Okay. Yeah, so this is a case that we developed for an insurance company where they had a model to predict insurance claims and how much they would cost over time.
Okay.
But it wasn't doing so well, and it wasn't updating real time, and it wasn't learning from historical data. So basically, it
Okay.
was a fixed model that they were using. Maybe every now and then they would tweak things, but not that much.
Okay.
And yeah, so that was the idea. And so yeah, so we're going through the series of showing off a few different case studies. Um, Sometimes we go through more details, others it's more about what was the business problem and how we go about to solving it. Uh,
Okay.
so let's see. And okay, so somehow this slide got in there, but basically like a definition of data science for anyone who's about to get started.
Okay.
At the end of the day, it's about like how much can you leverage both data and the modern tools for business insights. That's
Okay.
ultimately what it comes down to. The rest, it's more engineering. So that's always one of those things that are like, yes, you do need to know enough of the programming, enough machine learning, but at the end of the day, it's how do you leverage like knowing enough about what exists, the data that you have, the data that you can collect to gain those business insights and ultimately make business decisions.
That's good.
And so yeah, so during this week we'll be going through different case studies that we have been working on. So anything from, I think maybe like this week or next week we might do something in human resources, and maybe not for profits.
Yeah.
And so some examples, I'll go through the main case study, but some other smaller examples that I have worked on. The first one, the wearable devices. This was We worked on a case with medical doctors to analyze the data that they collect on bipolar patients or borderline bipolar patients.
Oh.
And so this was a research problem. This was actually a research and
Okay.
development. So we partnered with one of the hospitals, and of course, all the data was anonymized.
Yeah.
The idea was that it's very difficult to diagnose someone with a bipolar case, or even a borderline bipolar. It's a very
Yeah.
difficult thing to diagnose, and traditionally, what they would do is collect information where they would ask the patient different questions about like depression, for example, and mood, and so on. The question, and this was at least like that's where the research was, they had the features that they were collecting. There were about 120 features per patient,
100. Okay.
and of those features, most of it, more than 100 of those, they actually were questionnaires. So things that they would ask the patients to fill out. And one of the problems, there's two problems with that actually. One is that it makes the data collection very difficult. So if you want to collect more data, if you want people to volunteer to give you more information, answering over 100 questions, it's no one wants to
Tired.
sit down and do that.
Exactly. Yeah. No, it takes a lot of effort to convince people to go through that kind of
Yeah.
questionnaires. If
So
it's more than 5 or 10 questions,
yeah.
maybe it's fine, but probably with just 5 or 10 questions, even if they are really, really, really well designed, it for this type of problems, right? To
Yeah,
diagnose.
they did have some volunteers. They did collect some data on this, but their one of their main goals was to one of the main goals was to actually to help to reduce the dimensionality of the data, and the second
Okay.
one was to build an algorithm that could better predict based on the features that you're collecting, whether it's a yes or a no. The answer, like, is
Okay.
it
Perfect.
bipolar, yes or not?
Okay.
And so the main goal for us, the first goal was actually to use the data that they had started with and to
Hmm.
analyze it so that we could come up with the most important features.
The data that they had initially, it was the answers of the questionnaires.
Yes, so you
Right.
have,
Okay.
I think they had maybe like over 500 different members who answer those
Okay.
questions, and
Okay.
about, so the features are about 120, and then you have some, there was some information in there about demographics, about age, sex, and so on.
Hmm.
So now, so the ultimate goal, so we have, and the data was labeled. Data is labeled in that it's a yes or a no. Now, what you want to do is, so if you have 500 cases, you remove 100 cases, you build a new algorithm, and then you compare how your algorithm works compared to the algorithm that they had.
Okay. Perfect. Yeah.
And we were able to reduce the dimensionality to about 25 features. So from about
Ah,
120 to about 25 features,
yeah.
and while maintaining the predictability. So the predictive analytics, it was still actually not, like, we didn't lose much on that. It was about the same with the margin of error.
Okay. But
Uh,
the important thing here is that you reduce the
yeah,
dimensionality of
so
the data
reducing the
that you.
dimensionality, even if you lose a few points on the predictive analytics, it's not a big deal
Mhm.
because your ultimate goal is now, can you go from having just 500 people like volunteering to give you their data, but can you scale that up? So now when you have a much smaller
Exactly.
data set, it becomes more scalable. That was
Exactly.
the first phase. The future phases, and something that we're kind of like still in discussions, is to use that, but also combining it with wearable devices. So things that, anything like a Fitbit, for example, like a very simple Fitbit that now probably costs like 20 or 30 bucks. You could easily combine those questionnaires with alternative data. So that's when data science, a lot of value actually comes in, again, from the raw data. So you have the data
Hmm.
that you're asking, but then can you also combine that with data which is more passive? So if someone would be volunteering to give you the time series data, and then you have a lot of important informations there, like how someone is moving when you're very active and then when you're very still, and you try to get an idea from using that data. So that
Yeah.
was this case. So this is more on the research and the development side of things. And a lot of things that in medicine, image recognition is very big, because this is a pure data science problem. It's pure machine learning, in that if you're looking to predict cancer based on images,
Yeah.
and if you have thousands of images, it's just purely optimizing an algorithm that can predict. You have label data. So if you have a few thousand images and all of the images are labeled yes or no,
Okay.
then those are very good problems. Those are like ideal problems for a data scientist. Like, they don't happen
Yes.
very often, but like when you have those things, then like a lot of data scientists are very happy to work with these cases. So that's why
Yeah.
this area, image recognition in general, has seen a lot of improvements, at the point where the algorithm can do just as well as the medical doctor. And where I see this going, it's more in a becoming an assistant, where the doctor can actually use these as either a second opinion, or sometimes it can actually do better in the future. I think it can actually do a little bit better because it can keep up with a lot of the research. So if you can combine image
Yes.
recognition with papers that are being published continuously,
Yeah.
you
There's
should
a
be
lot of
able
people.
to actually do a little bit better. And as a human, sometimes it's difficult to keep up with all the research.
Yeah. Exactly.
So that's kind
Well,
of where I see
probably.
a lot of this on the image recognition side.
And probably it will help towards the invasive part of detecting like biopsies and things like that. So probably it will reduce the that effect,
Yeah.
right? Instead of being submitted to, I don't know, to one or two biopsies to recognize if it is cancer or not, it will help eventually to prevent that. No,
And
that's
so
great.
the thing is, it's like this doesn't necessarily move the human element. I think, especially medicine, it's very human based.
Exactly.
But
Exactly.
it can make the job of a medical doctor much easier, so they can focus more on
And more
other
accurate.
things,
Yeah.
like just like
And more
talking and
accurate.
like figuring out like what works for a specific person and what doesn't, what is actionable, what is not.
Yeah.
So that's where these things ultimately lead into.
Yeah.
And okay, so another like specific. So now we'll give one specific case that we worked on for insurance companies, and which is what I mentioned. So it's predicting insurance claim costs using historical data. So you have a new claim that comes in. Someone went through maybe like an operation, maybe some surgery, and or anything that could come into the door of the insurance. The goal for some of the people working in actuaries is that, and it takes time from the moment that a claim comes in to when you pay for that claim. So sometimes the lag time can be a few months, and having when you're a large insurance firm and you have a lot of volume, like understanding where you're going to be 3 to 6 months from now can make a big difference, because you could be
Yeah.
plus minus a few $1 million, if not more.
Yeah.
So getting like having an idea as like where you are going, because then you might have to adjust what you are like, maybe how much you're paying, but a lot of things can come out of that.
Yeah. It's a long
So
process.
that was the idea, to use the features that they have and the data that they have to predict whether something is going to be, for example, expensive or not expensive. Like even that by itself, like creating certain categories, like that by itself is actually very useful.
Yeah.
So basically, the needs were to first improve the existing model. The second one is that when you have
The
a
model,
model, like
sorry, the model that you were trying to improve, it was the original model from the
yes,
company.
yes.
Right. Okay.
So that was the first step. The second step is that having a model is nice, but ultimately you want to automate that part, in that you don't want to have like a formula somewhere out there and then ask an analyst like, okay, like enter these things into the formula, and then you get like a yes or a no or the
Yeah.
prediction. So ultimately, so you have the model. When you're satisfied enough with the model, it's very important in this case is that you actually automate that process, and you
Yeah.
build an interface for the analysts to use.
Okay.
So first, building the model, building the interface. So the interface can be anything simple. In this case, we use R for a lot of these things.
Okay.
Until you go full scale, it actually works very well. And then the third step is that you build the model, you optimize it, and now you have new data coming in. So that, how do you adjust your weights? Say
Mm-hmm.
that you predicted something, but that doesn't necessarily come out to be true. How does your model learn from this new incoming data? So that's the third step, basically. So that's when the machine learning is very important, in that you build something, you fix it for a little while, but then it could be real time, but usually for these cases, you could do it like every month, for example, you update the model.
Yeah, there are other cases, for example, in finance, right? That the updating of the model, it has to take place in
Yeah.
shorter
Yeah. So
periods of time,
yeah, so
not a
sometimes
month.
it needs to be
It
exactly
depends.
real time, but
Yeah,
in a lot of cases, it could be like anything from like a few days to even like a few weeks,
please.
depending on, because
Okay.
there is cost and there's a lot of things to take into consideration.
Okay, perfect.
Um, so in this case, like some of the things that we were looking to predict is actually break it down by region. So once you have all of the data, looking into the region, looking into the claims. So I'll actually go
Okay.
into what the prototype of this looked like. So the prototype would look something like this, where you have the injury type. So you pull the injury. What kind of injury is the member having?
Mm-hmm.
Another of the feature was the location. So you pull also the location. So these were some of the
Okay.
things that internally they were interested in. They wanted to know at a high level. In the background, the algorithm, everything is in the background. But what was actionable for them, they wanted to know, okay, based on this injury, and then based on this location, give us an idea whether, at first, it was whether this is going to be expensive or not.
Okay.
And how to do that, you sit down and you tell them, okay, what is expensive in this case? Or you can analyze the data and then you say that, okay, what is the average cost per claim? And then you can have some sort of a distribution. From there, you create categories. So the categories, like the first two categories that we created were just binary. Is it going to be expensive or not? And then you move into
Okay.
more categories. So then you can go from anything from level 1 to level 5 based on how expensive something is. So you just have brackets. And
Okay.
then you map everything into one of the brackets. And the other thing that was also important to know is like these outliers. Sometimes when you have a data set, you can get a
Mm-hmm.
prediction, but if the data is an outlier, you probably want to let the analyst know that even though we're making a prediction, we don't have that many of these cases, so you should probably dig into the case yourself. So meaning that like we're
Okay.
not very confident in our data set, so you should actually go and dig in. Like we'll give you
Yes.
a sense, but this is when but this already like minimizes the work for the analyst in that okay, you start with a lot of cases, you automate the easy cases, and now you
Exactly.
focus on the outliers. The outliers, they still need someone with more experience because you don't have enough
Yes.
data to build that model. So you kind of have
With
someone
bigger confidence.
exactly.
Yeah. Okay. Perfect.
And anyway, so that was basically the tool looks something like this, where you pull down the algorithm, everything is in the background, so the analyst and any decision makers, of course, we have to show them how well it performs, but they don't need to know.
Exactly.
This is just a distribution to get an idea. We were talking about outliers, so like getting a map for each claim, it'll tell you like where does
Mhm.
it fall in that distribution.
Okay.
And this is log based because otherwise it was too spread out. And
Okay.
okay, so then now let's go through. This is very important, the methodology and the hypothesis testing. So this is when so you have a new case coming in, and how do you go about step by step? So the first you start with the first question. So this is something that we start with: how well is the current model performing?
Mm-hmm.
Now, in this case, actually, they did not have a metric. They did have a model, but they had no metric. In that, if I asked you, it's like, okay, in the past 30 days, how many cases did you predict correctly? How many of them did you miss? And by how much did you miss them?
And they didn't have
So
that.
that didn't exist. Like they kind of like have an
Okay.
idea, like the analysts, they kind of have an idea on like what they're missing and what they're not, but they didn't have it. For us, that's important
Okay.
because we need to build something and then we need to compare. Like we need to have a benchmark. So the
Yeah.
first step for us was to help them design metrics for their current model. So it's like, okay, like let's sit down, let's figure out like because it's easy. You can just pull up maybe like three to 6 months of data, and then you say, okay, what is your model? Let's run it. Because the automation part wasn't there, so just automating it and then putting some, and then that's your benchmark. So anything that you build, because that's eventually like how do you show the benefits of your algorithm. So anything that you
Exactly.
build needs to outperform the existing model at the very least.
For Yeah, for example, for the people out there who watch, I think if I remember correctly, on Monday that we present the sentiment analysis, we describe there exactly what a metric is, right? That you can define like a formula or something that gives you a number, right?
Yep.
Depending on the problem that you are working, and then you can compare everything else
But I mean,
with
in this
that
case,
number
yeah, I
that
mean,
you
in this case,
obtain.
for example,
In
it
this case, it's
was.
a little bit different, but
But I
yes,
mean, in
of
this case,
course,
it's like, are you predicting 80%, 60%, 70% of your cases
correct,
correctly? Yes or no?
exactly,
But then you can go, but then you do have to help them design because what are you predicting? Are you predicting the exact cost? Or are you predicting categories? So for us, it was
exactly.
since we were going to work with categories, so then we have to create these buckets. and then how many of those
Okay.
buckets you're getting correctly, how many of those buckets are you missing. So that was the first step. So then very quickly, like the first thing that you do as a data scientist then is like, okay, let me test myself, like very quickly, can I do better than that model? Yes or no? Like if the answer
Okay.
is yes, then okay, like let's move on to the next step. Now, just because you can improve something, like how well can you improve it is also very important, because if you improve something by maybe like 1 or 2%, and if that's within like margin of error, or even does it
Yeah.
justify the cost, basically? Does it justify the cost of implementing a new model into your workflow?
And for example, in your experience in these kind of cases, how much improvement is considered like well done?
There's no universal. It'll depend on like
No.
on the stakes. It'll depend on the volume. So
Okay.
if you're working for a hedge fund, and if you can improve their algorithm by 1 or 2%,
Mm-hmm.
that's great, because you're doing so many transactions every minute
Okay.
that at
It
the end of the
depends on the
month that
range of
actually really adds
things.
up. So
Yeah.
yeah, it depends on a case by case basis. So
Okay.
in this
Perfect.
case, we tried a few different models, and eventually we ended up using, for anyone who's out there, like random forests from machine learning to
Uh-huh.
improve the model, and it was actually over 20%. And so this
Oh,
showed that okay, like the what was in place at that moment was, it very much relied on the humans, but there wasn't anything, because as you have new analysts coming in, it's very difficult sometimes to train them to think like the one who has more expertise. So this doesn't mean that it was doing better than all of the analysts, but on average it was doing better than them. So
better.
you might have like an
Okay.
analyst who's been there for maybe like 20 or 25 years, that like
That he's really
yeah,
good.
so like that particular person might actually do very well. So you want the model to actually learn from those people.
From the
Yeah.
best ones. Yep.
So that was the next hypothesis, and then the next one is to build an interactive tool. So that was the Shiny app that I showed. So now that you have all of
Okay.
this, saying that you have a random forest model, it doesn't do anything until you can actually implement it and then run it live.
Okay.
And then the last one is, yeah, the numbering is okay. So the last one is basically to learn from new data. And like I said, like in this case, we didn't do real time, because you have claims coming in every minute or every second. There's a cost factor in there, in that you have your model, which is running on AWS. If you have too many interactions, the way that the
Mm-hmm.
AWS, like all of these cloud computing platforms, they're very inexpensive to store data. They can get
Mm-hmm.
expensive very quickly the more you interact with your database.
That's
So every time you update the
yeah.
model, that's a cost. So then you sit
Of
down and
course.
then you say, okay, these are the costs. Like what makes sense for this case. So in this case, like even like a 24 interval was like good enough. But in the beginning, like even like a weekly thing, because you don't have enough going on. So basically, that was the idea. So that was, and then the next level, you can actually do better. So that's when you go from, this is the data that you are giving us. Now let's ask our own questions, like what else can we do to make better predictions? Something that is very important, and it's undervalued, it's the notes from the doctors. So
Ah, okay.
each case, when a new claim comes in, he has this little box with notes.
Okay.
These notes, sometimes an analyst might sit down and might write something, might create some categories based on those notes. But actually going through it and building and like understanding what features are important from those notes can actually be very, very important. So that was actually one of the
Yes.
features that we wanted to add into in the future. And that's it.
Oh, that's
Yeah.
it. And NLP, for those who are out there, we have the seminar on Monday, I think. So you can cover that part of NLP and how to use the doctor's notes in this case. So I have one
Uh huh.
question here. For example, this kind of projects, because it's a big
Yeah.
one, right? For a more or less big company. How long it takes in the advisory part? How do you go in and after the first contact, probably they approach you and tell you like, oh, we have this problem. right?
Yeah, so sometimes it
We are losing money. So how long it takes, for example,
so
of course,
there's two
depending on the
cases.
people that.
So there's two cases.
Uh-huh.
One is when the client already has a data science team, and then another one is when the client does not have a data science team. When the client has a data science team, or maybe they have some engineers, some data engineers, some people who are doing statistics, then it's more on
Okay.
the advisory in trying to get their team to move in the right direction. So it's
Okay.
more like weekly check-in points. To move faster, then I usually bring in my own team because of the communication part, and we have worked together for longer periods of time. So in this case, we actually built the entire thing from scratch. But it
Okay.
doesn't take long. I think at least like building the first, like showing the proof of concept, showing the prototype, it's something like
Okay.
4 weeks. So anything,
For
yeah.
weeks.
So like
Oh,
4 to 6 weeks, you actually have something that is like up and running, and then, but yeah, basically that's the idea. So do you?
yes. And as you said, it's from the
Yeah,
scratch. They had nothing.
yeah. So those are the two cases. So like building it from
Okay.
scratch, and then the other case is the advisory because sometimes you're not ready to move into like the building, and you might just
Okay.
want to improve what you have or using your resources to move in the right direction.
Okay.
And very often there's a mismatch between the expectations from the business leaders and the teams, the internal data engineering or data science teams. Because just because like engineers are good at building things, and then but then there's like sometimes there's a mismatch in like, are we building the right thing? Are we putting our resources in the right place? So
Okay.
those are the roles on the advisory basis. Uh,
Okay.
yep, good.
Yep. Yeah, it is really good. We have a question in the
Uh
chat.
huh.
What is the topic for tomorrow?
Tomorrow. I think
Yeah, tomorrow is gonna be a lighter
so.
day, right?
Tomorrow, I think we're going to focus more on. Yeah, it's Friday, so it'll be more actually on new data scientists who are interested in, well, both people who are interested in moving into data science and those who
As
are
a
in data
company.
science, like how, like what they should be working on, what kind of skills they should be working on.
Yeah, that is really important because I think we had it like a couple of weeks
Yeah.
ago. The question of what is the difference between a person who just codes and a data scientist. So tomorrow we're going to be covering that too, the skills that you have to develop, right?
Yeah, and I
And
think we have a lot of value to add in there because um, we come from non-traditional fields, but
yeah,
also like from having worked in I don't know how many different case studies. Like I know exactly what like someone needs, like what kind of skill someone
out there.
needs based on
Yeah.
their background. In that you don't need to spend like a few years going around learning a lot of things, but like so like pinpointing exactly what you should be focusing on at least to get started. And then so there are like the must-haves and then the nice-to-haves. So that's
Okay.
that's the idea. Good.
That's it. Yeah.
Okay.
Good. I think it's good. Thank you
Ciao.
so much. And the end, if some for the advisory, there is your email, shehu@byteflows.com. You are the principal AI researcher at Byteflows. And I'm Gina Olivares. My email also. You can contact me if you want to know more about these things, or if you're ready to go and implement data science. My email is olivares@byflows.com, and we hope to see you tomorrow at 12 Eastern time. And
Bye.
thank you so much, everybody out there. Thank you so much. Bye bye.